Far out in the Pacific, beyond the reach of shipping routes, and far from any major landmass, lies one of the most extraordinary volcanic structures on Earth. Known as Pūhāhonu, this colossal volcano is largely invisible to the human eye, hidden beneath thousands of meters of ocean water. Only a small cluster of rocky outcrops, called the Gardner Pinnacles, hint at the immense geological structure below. But what lies beneath those jagged peaks is in fact the largest volcano on Earth by volume, dwarfing even the famous Mauna Loa. For decades, Pūhāhonu remained relatively obscure, overshadowed by more accessible and visually dramatic volcanoes. Yet modern scientific investigations have revealed a startling truth. This ancient giant is not only massive, but also incredibly complex, unusually hot in its origins, and potentially more significant to Earth's geological story than previously imagined. Pūhāhonu belongs to the Hawaiian Emperor Seamount Chain, a vast line of volcanoes formed as the Pacific Plate moves slowly over a stationary hotspot deep within the Earth's mantle. This same hotspot is responsible for creating the Hawaiian Islands, including well-known volcanoes like Mauna Loa and Kilauea. But Pūhāhonu tells a story from much further back in time. Formed approximately 12 to 14 million years ago, Pūhāhonu represents an earlier phase of hotspot activity. At that time, conditions deep within the Earth were different. The mantle plume feeding the volcano was likely hotter and more vigorous, producing enormous volumes of magma over extended periods. This allowed Pūhāhonu to grow to a staggering size, estimated at around 150,000 cubic kilometers of rock. To put this into perspective, Pūhāhonu is nearly twice the volume of Mauna Loa, long considered the largest volcano on Earth. However, unlike Mauna Loa, which rises above sea level and continues to erupt today, Pūhāhonu is almost entirely submerged. This hidden nature is part of what makes it so fascinating and so mysterious. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. One of the most surprising discoveries about Pūhāhonu came from the analysis of its rock samples. Scientists studying the mineral composition, particularly the presence of olivine crystals, found evidence that the magma which formed this volcano reached extraordinarily high temperatures. These temperatures were estimated to be around 1700 degrees Celsius, significantly hotter than typical Hawaiian volcanoes, which usually erupt magma at temperatures closer to 1200 to 1300 degrees Celsius. This makes Pūhāhonu not only the largest volcano by volume, but potentially the hottest volcano ever identified on Earth. Such extreme temperatures suggest that the mantle plume feeding Pūhāhonu was far more intense in the past than it is today. This has major implications for our understanding of Earth's internal dynamics. It indicates that mantle plumes can vary significantly over time, producing periods of extreme volcanic output followed by quieter phases. Pūhāhonu may represent one of the most powerful expressions of this process ever recorded. Unlike volcanoes that erupt on land, Pūhāhonu developed almost entirely beneath the ocean. This environment dramatically changes the behavior of lava. When molten rock meets seawater, it cools rapidly, forming distinctive structures known as pillow lavas, rounded, bulbous formations that pile up layer upon layer across the seafloor. Over millions of years, repeated eruptions built up an enormous underwater mountain. At its peak, parts of Pūhāhonu likely rose above sea level, forming temporary islands. But as volcanic activity waned and the oceanic crust cooled and subsided, the entire structure slowly sank beneath the waves. Today, only the most resistant remnants remain exposed. The Gardner Pinnacles are essentially the eroded tips of a once massive volcanic island. Beneath them lies a vast submerged landscape of lava flows, collapsed calderas, and ancient volcanic structures that are still only partially mapped. Pūhāhonu is generally classified as an extinct volcano, meaning it is not expected to erupt again. Its formation is tied to a hotspot that has since moved far away due to the motion of the Pacific Plate. In theory, the magma supply that once fed Pūhāhonu has long been cut off. However, in geology, the line between dormant and extinct is not always absolute. there are cases where volcanic systems thought to be inactive have shown unexpected signs of renewed activity. While there is currently no evidence that Pūhāhonu is reactivating, its immense size and complex structure mean that scientists cannot completely rule out all forms of geological activity. For example, residual heat within the volcanic edifice could still drive hydrothermal systems, where seawater circulates through hot rock, creating vents on the ocean floor. These systems can influence local ecosystems and, in some cases, contribute to chemical changes in the ocean. More importantly, the structure itself remains a massive geological feature that can interact with surrounding tectonic forces in unpredictable ways. At first glance, Pūhāhonu may seem harmless. It is remote, submerged, and long inactive. There are no visible eruptions, no ash clouds, no lava flows threatening nearby communities. Compared to active volcanoes, it appears to pose little immediate danger. But this perception can be misleading. One of the most significant potential dangers associated with massive oceanic volcanoes like Pūhāhonu is the risk of submarine landslides. Over time, the steep flanks of volcanic structures can become unstable. Layers of lava, ash, and sediment may weaken, especially under the influence of earthquakes or gradual structural changes. If a large section of Pūhāhonu's flank were to collapse, it could trigger a massive underwater landslide, displacing enormous volumes of water. This, in turn, could generate a tsunami capable of traveling across the Pacific Ocean. While such events are rare, they are not purely theoretical. Geological evidence shows that similar collapses have occurred in the Hawaiian Islands in the past, producing large debris fields on the ocean floor. These events are capable of generating waves that could impact distant coastlines. The remoteness of Pūhāhonu reduces the immediate risk to populated areas, but the scale of the structure means that any major collapse could have far-reaching consequences. Even in the absence of volcanic activity, Pūhāhonu remains part of a dynamic tectonic environment. The Pacific Plate continues to move, carrying the ancient volcano along with it. This movement can generate stress within the oceanic crust, leading to earthquakes. Although most of these earthquakes are relatively small, they can still play a role in destabilizing the structure of the volcano. Over long timescales, repeated seismic activity may weaken the internal integrity of the volcanic edifice, increasing the likelihood of slope failures or other forms of structural collapse. Additionally, the immense weight of Pūhāhonu itself places pressure on the underlying crust. This can lead to gradual deformation, further contributing to instability. These processes are slow and often invisible, but they are constantly shaping the structure from within. Beyond its physical size and potential hazards, Pūhāhonu holds immense scientific value. It provides a unique window into the behavior of mantle plumes and the evolution of volcanic systems over millions of years. By studying the rocks and structure of Pūhāhonu, scientists can gain insights into how Earth's interior has changed over time. The extreme temperatures associated with its formation suggest that mantle plumes may undergo cycles of intensity, producing periods of unusually high volcanic output. This has implications not just for Hawaii, but for volcanic systems around the world. Understanding these processes could help scientists better predict future volcanic activity and assess the risks associated with large-scale geological features. Pūhāhonu stands as a reminder that some of the most powerful forces on Earth are also the least visible. Hidden beneath the ocean, far from human observation, this enormous volcano tells a story of extreme heat, immense scale, and dynamic geological change. It challenges our assumptions about what defines the largest or most dangerous volcano. It shows that size alone does not determine visibility, and that some of the most significant features of our planet remain largely unknown. While Pūhāhonu may never erupt again, its presence continues to shape the ocean floor and influence the geological processes of the Pacific. It is a silent giant, one that demands respect, not because of what it is doing now, but because of what it represents. In the vast and largely unexplored depths of Earth's oceans, there may be other giants like Pūhāhonu waiting to be discovered. And with each new discovery, we are reminded that our planet is far more complex and far more powerful than it appears on the surface.